This is the key to quiz 2, and this is version 2. And in the first problem, first of all, the direction says solve each equation. You must show the work as presented in class to receive full credit, and make sure all statements are mathematically correct. All right, so number 1, you have this radical equation. Now, this radical equation is a square root equation. When solving a radical equation, you need to get the radical by itself, and in this case, it already is. So the square root is already on one side. There's no other term on the other side. All the other terms are on the left side. When solving a radical equation, I'm going to go ahead and rewrite this over. So you have x minus 3 equal the square root of 30 minus 2x. When solving a radical equation, you raise both sides. Notice I enclosed the parentheses like this. You raise both sides to a power that's equal to the index. So the index in this case is 2. Square root index is 2. So I'm going to square both sides. All right, now let's go ahead and square each side. Now on this left side, I have a binomial squared. So that means, and if we go off and do the work here, let's say we do the work here, that means x minus 3 times x minus 3 equal, and on this side, the square root and the square, they're inverses of each other, so you just get the radicand, so that's 30 minus 2x. All right, now on this side, let's go ahead and multiply these two binomials out. So using a FOIL, x times x is x squared. The outer is negative 3x. The inner is negative 3x. And the last is a negative 3 times a negative 3 is a positive 9. And that's equal to 30 minus 2x. Combining like terms, now notice I have this quadratic equation now. So this is a quadratic equation because the largest exponent is 2. All right, so I get, combining like terms, I get x squared. A negative 3x and a negative 3x is negative 6x plus 9 equal, and on this side there's nothing I can combine, so that's 30 minus 2x. All right, and when solving a radical equation, you want to bring all the variables all the terms to one side. So I'm going to go ahead and add 2x to both sides. What I do to one side, I do to the other. Combine like terms, I get x squared. A negative 6x plus 2x is a negative 4x plus 9 equal. And when I combine these, that's 0. I'm left with 30. Subtract 30 from both sides. Notice I'm aligning my like terms. I align my like terms. And so combining like terms again, I get x squared minus 4x minus 21 equal 0. All right, now I have this quadratic equation. It's in standard form. So let's go ahead and see if I can factor this. If I couldn't factor, I'd have to use a quadratic formula or completing the square. But most students revert to using the quadratic formula. All right, this could be factorable. This is factorable, so I'm going to go ahead and factor this. So I'm going to need a 7 and a 3, and this would have to be negative, and this would have to be positive. All right, so I factored x squared minus 4x minus 21 as x minus 3 times x plus 3. I set each factor equal to 0, and when I do that, I end up with two linear equations, so I solve each one. So one of my proposed solutions, I'm using the word proposed solutions, one of my proposed solutions is 7, and the other is negative 3. Now the reason I call these proposed solutions is because of this. These two values, they are solutions to this quadratic equation, and this quadratic equation is equivalent to this one. So these are all solutions to this equation, these equations, but they may or may not be solutions to the radical equation. Whenever you raise both sides to even power, remember in our discussion, you tend to sometimes produce extraneous solutions. So these are now called proposed. I need to check to see if they're actually solutions to the original equation, to the radical. So you have to check. So let's check x equals 7. And you go back to the original. So the original was x minus 3 equal the square root of 30 minus 2x. So wherever we see the variable x, I'm going to substitute 7. So I get 7 minus 3, and I want to see that's going to equal the square root of 30 minus 2 times 7. And so 7 minus 3 is 4. Again, I want to see that's going to equal the square root All right, now 2 times 7 is 14. 30 minus 14 is 16, and yes, the square root of 16 does equal 4. All right, if I check x equal negative 3, I get, again, go back to the original. And so where we see the variable x, I'm going to substitute negative 3. So I get negative 3 minus 3, and I'm going to see that's going to equal the square root of 30 minus 2 times negative 3. Negative 3 and a negative 3 is a negative 6. And I'm going to see that's going to equal the square root of, now 30, a negative 2 times a negative 3 is a positive 6. So that's going to be 30 plus 6, which is 36. Now here's the issue. This is negative 6. This is positive 6. Those are not equal. Those are not equal to each other. So that implied that this right here was this proposed solution. Although it's a solution to this quadratic equation, it's not a solution to the radical equation. So remember, this is called the extraneous root. All right, so the only proposed solution that's a solution to the original equation is x equals 7. So you did have to check your solution. All right, now for the absolute value equation, just like over here where you had to get the radical by itself, here you have to get the absolute value by itself. So I need to subtract 4 from both sides. So notice the steps that you have to do. So this becomes absolute value of 5x minus 3 is equal to 6. Now once you get that part right here, remember when in our discussion in the lesson, whenever you get the absolute value by itself, that's where you're going to break this down into 2 equations without absolute value bars. So this becomes 5x minus 3 equals 6, and the other solution you can get by saying 5x minus 3 equals a negative 6. All right, so remember you got to take this number over here and rewrite it twice. So this stays the same. This becomes 6 and a negative 6. So in our discussion we talked about the opposite sides of 0 when we talked about absolute value. So that's why you see these as being opposites. All right, but notice I went from a absolute value equation to 2 linear equations. So I'm going to add 3 to both sides, and so I get 5x equal 9, and so x is 9/5. So that's one of your solutions. Over here, I'm going to add 3 to both sides. I get 5x equal a negative 3. Dividing both sides by 5, I get x to be a negative 3/5. All right. Now you don't have to check these, but if you could if you wanted to, but those are your solutions. So the solutions are 9/5 and negative 3/5. 9/5, negative 3/5. All right. So that's going to take care of the key to quiz 2 version 2.